Alright guys, today is really exciting because we get to cover the chain rule today. And so this is a rule that we're going to be using all the time. It lets us take all sorts of derivatives. And it's something that you actually probably have a little bit of intuition for how to do. And so what the chain rule is going to do is it's going to allow us to take the derivative of something like this. And now I know I've warned you against this, but if you had to guess, how would you take the derivative of a function like this? And now I never want you to guess when you're actually taking derivatives, right? You should know every exact step you're taking. But if you were just looking at this, you might kind of notice that, well, this is kind of like just when I have x to the 7th, right? And so you might guess, well, maybe I can just do the same thing, right? I can bring my exponent down. I can do 7, and then leave that thing in parentheses. And then on the top, I'll do 7 minus 1, right? And so then I would just fill in what's on the inside, right? It's kind of just like x to the 7th, right? I'm kind of just doing the same thing I was with x to the 7th. And so I do 4t plus 1, and if I simplified this, it would be equal to 7 times 4t plus 1, all to the 6th power. Now, if you did this, you would actually be pretty far along the right way, but you would be wrong. All right, so what happened here? So this is actually some really good intuition to have, so let's build on it. All right, so the big idea is let's come back to the same problem. All right, I want to take the derivative, but I want to do it right this time. And so on my kind of path to doing it right, I want to identify f of x and g of x such that f of g of x is equal to this thing. And now this is something we practiced a lot in chapter 1. It's called decomposition of functions. You can go back and look at composition and decomposition of functions if you want to, but remember the kind of the words we like to use were outer function and inner function. So f is kind of an outer function and g is kind of an inner function, right? And so if you remember, kind of the intuition was g was the type of thing, g was the thing you needed to type into your calculator first, and then f would be the thing you kind of do at the end, so to speak. Right? And so with this problem, the first thing you need to type into your calculator is this 4x plus 1. It's inside parentheses, right? It's kind of the first thing you need to do. And so g of x would be equal to 4x plus 1, and then f of x is going to be your outer function, and that's just going to be whatever that is to the 7th, and it's f of x, so I'm going to write x to the 7th. But remember, the big idea is f of g of x is equal to this thing. So kind of I can help you out maybe by putting g of x in square brackets, and I'll put all my x's in f of x in square brackets. There's only one here, so it's a little bit easy. But the big idea is if I replace the input of f with the g of x, I'll get this equation over here, right? So you need to be able to decompose the functions. What's the inner function? What's the outer function? Now, what the chain rule tells us is that what we had done first was almost right. So we want to do what we did before, all right? So to do d over dx of 4x plus 1 to the 7th, we do what we did before. So we do that thing where we take the 7 down, and we do 4x plus 1 and to the 6th power, but we're going to multiply it by the derivative of our inner function, right? So we have to do this other part here, where we multiply it by the derivative of our inner function. Now look at g of x. G of x is just equal to 4x plus 1. So g prime of x is going to be equal to, what's the derivative of 4x plus 1? It's actually just 4, right? This is a linear function, right? It's actually just 4. We can use our power rule. And so we have to multiply this by 4. So our final answer would actually be, if we simplify this, if we multiply the 7 and the 4, it would be 28 times 4x plus 1 to the 6th power. Okay, so let's write this out formally. But kind of the intuition we're getting so far is kind of do what you might do naturally, but multiply by that derivative of the inner function. Right? So the actual kind of rigorous definition here, this actual rule, is that the derivative of a composition of functions is equal to, now this looks like a mess here, right? This looks awful. But let's go back to our old example and kind of see what all these terms mean, right? So here's the example we already did. We already remembered that g of x here was 4x plus 1. G of x is our inner function. F of x is our outer function, x to the 7th. And so to kind of help us kind of figure out what all these different terms mean, let's write down what f prime of x is. So f prime of x is 7x to the 6th, and g prime of x is just going to be 4, right? So when it says f prime of g of x, this is actually the thing. So f prime, so here's my function f prime. So I would do 7, but instead of f prime of x, it's doing f prime of g of x. So I have to replace the input of f prime with g of x. So I have 7 times my square brackets. I'm replacing it with g of x, so 4x plus 1, all to the 6th power, right? So this term here is the term that we were able to get just kind of by using our intuition, right? Just saying, well, if I look at this thing and want to take the derivative, I'm just going to bring the 7 down, turn it into a 6, and I'll be done with it. But the part the chain rule adds on is that we have to now multiply this term here by the derivative of g of x, which is just this part down here, by the 4. So big idea, break it up to an inner-outer function. And so this chain rule says, well, you take the derivative of the outer function, leave the inner function where it was. So I'm taking the derivative of the outer function, I'm taking the derivative of the f, leaving g where it was, and then multiply by the derivative right here of the inner function.